Let's talk about how special result cases are created where you combine many different types of analysis cases, and we'll talk about envelopes as well. In this example problem, I have a 3-span continuous beam with loads that are applied as snow loads, live loads, and dead loads. And if we go to Load Case Manager for load combinations, we're just doing ASD cases for our design. What I want to do now is go to the Advanced Cases tab in the Load Case Manager. If we take a look down at the bottom, we have the ability to create a result superposition case, and I'm going to select that now. And when I do that, I have the ability to name this special case, whether I'm going to include it in analysis, and then what kind of design is it going to be used for, either strength, allowable, which is what we'll set up because most of my cases are at allowable level, and whether we want to use seismic overstrength or not. Once I do that now, I have the ability to combine cases, and I'm going to create a case where my result superposition case is dead plus live. So I'm going to use a 1.0 factor for this case, and notice these are the generated cases based on building code here. We have the basic service cases as below if we want to add those. And lastly, the special thing now, we can take this dynamic response case and include it in the combination as well. Please note that the building code generator of these first set of cases cannot combine a response case directly, so you have to do it manually here because it doesn't know the source of the response case. So I'm going to select 1 in this case, and now I've created a special result superposition case. Let's close out of that now and look at results. And when I do that, you can see I have several mode shapes because I have a mode shape case. I have my service cases and my building code generated combinations. I have the results of my response case, and now I have the result superposition case. And when you create a result superposition case, it's actually going to create 2 cases for you, one with the high extreme values for all of the results, and one for the low extreme values for all of the results. These are the low extreme values, and as you see, the deflections are downward or negative. So in order to combine things like time history and response spectrum analyses with your regular building code cases so you can design, you will need to then go to the Load Case Manager and create one of these result superposition cases. The last thing I want to show you is that on this tab we have the ability to calculate envelope results. If I check that box and now look at what I have for results, I'm going to have the normal cases, but in addition below here I have an all load cases, low extreme and high extreme. And all load cases means I'm going to take every case you see in this list, all except the mode shapes here, and create an envelope value for low values and high values. I'm also going to create an envelope for all the ASD cases that were generated. And if I had LRFD cases, I'd get envelopes for those as well. Let's look at one of these. Let's look at the ASD low extreme envelope. And it's important to point out that envelopes are not truly deflected shapes of a real load. These are just the lowest values possible from all of the cases it checked. As you can see, all the deflections are negative. If I select all of these members and go to a member graph, you'll see that we get to see all of the moments, shears, and deflections for that case. Let's now go back to our results, and this time let's select all load cases extreme and select our members again and go to the member graph. And now we see something special when we do the all cases extreme. We actually see in the member graph the bounding lines for both the high and the low values. And so we're seeing that for moments and shears. We only have bending in one direction, so these other 3 down here at the bottom are 0, but we're actually seeing then what you would say from analysis, kind of a classic envelope diagram. We get to see both plotted to make an area on the curve.